If creating testing scenarios for people classification, identification, verification, deduction, segmentation, and recognition use cases across various industries is a tedious process, knowing how to perform them right is another game altogether. Hi, this is Alphonse, and in today's edition of Unraveling Computer Vision and Edge AI for the Real World, I'll be talking about how to choose the right testing methodology for your people deduction systems based on use cases once the testing scenarios are chosen. I've spoken about how to choose the right testing scenario in a previous vlog, and the link for the same is in the description accompanying this vlog. That being said, speed and accuracy are the two major parameters you want to test in a people deduction system depending on the use case. Now that these testing scenarios are chosen, there are two common ways in which you can test your scenarios, and they are database testing and real-time deployment testing. Dataset-based testing is the most conventional and one of the oldest methods of testing, not just in people deduction solution, but any object deduction solution in general. This method involves an enormous effort as we have to generate the ground truth for the test dataset. The ground truth is nothing but the manually annotated dataset. Manual annotation is nothing but the labeling of images with bounding boxes to exactly point out where the real objects are. Once the ground truth is developed, testing and the prediction result is just a click away. At VisAI Labs, metrics available such as average precision and mean average precision are used to identify the accuracy of the model. Also, please make sure the dataset on which the model will be tested is not the same which will be used for testing and modeling. I know this sounds elementary, but it's important to have separate datasets as the given model would have already seen these datasets in the training stage. This means that testing it with the same dataset will give you a higher mean average precision. But that higher accuracy will not give us the confidence that this model will work better on unknown data. So the dataset for testing should be from the same domain as the training and the validation dataset. But this dataset should not have been part of the testing or validation dataset. Also, getting the average precision or the mean average precision alone is insufficient to holistically understand this model, because sometimes the mean average precision is improved because there might be an increase in false positives, and this is not good for the real world model. So in addition to accuracy metrics, which is useful for quality assurance, we have to do some definitive tests for the behaviors we expect our model to follow. So in addition to metric based tests, explicit tests are also needed to build these high quality models. So what are explicit tests? There are actually two kinds of explicit tests we in VisAI Labs use. It's the invariance test and the minimum functional test. In the invariance test, we check the model's prediction consistency. Here we introduce some changes in the input and see how the model reacts to the changes. For example, if you have two images containing a person, but one image is in a bright environment and the other image is in a dark environment, then our model should be tested to detect a person in both images. Well, but now in minimum functional tests, what we do is we define a set of test cases with the model's expected behavior. And what this does, it helps us quantify the model performance in different scenarios. For instance, you want to set up tests to identify the model behavior when there are excluded persons or in crowded scenarios. This is the way to go. While dataset-based testing restricts you to a test within a specified series of images, real-time deployable testing allows you to test over time with different inputs. But this method is not as straightforward as the dataset testing approach, wherein it does not provide you, with this quantified precision metrics, and you can only visualize the predictions. But this builds very high confidence on the model. Since data processed in real time is really large, we should just focus on motion-based sample testing and person count-based testing when we do real-time deployment testing. In motion-based sample testing, instead of processing every frame from the image stream, we can run our model and check its prediction accuracy only when there is a motion detected. This way, we can reduce the human effort to monitor the system continuously. And in person count based testing, we can count the number of persons deducted by our machine learning algorithm based on people detection model against some ground truth. But this approach requires integration with a people tracking solution. So then we can link this deduction accuracy to the tracker's accuracy. Sometimes here, my team at VisAI Labs actually uses infrared-based sensors to count people walking by in the given zone and compares it to the computer vision solution. Of course, the assumption here is that the IR sensor is perfect when really it isn't. So truthfully, testing people detection solutions requires massive efforts and an understanding of the metrics. This consumes time and energy from the engineering and product management team, where instead of building the business application logic, the team is focused on building the machine learning algorithm. At VisAI Labs, we have built a series of tunable people detection algorithms which can help you identify dwell time, congestion time, intrusion, people counting, tracking, etc. And we have already pre-tested it across various scenarios such as indoor or outdoor, as well as for various scales from people identification at close range to mass density identification in concerts, malls, etc. In addition to making sure it's deployable in various types of edge processors and embedded cameras, tested both in simulated and real-life testing conditions. You can check out the link in the description to learn more about VisAI Labs' pre-built people detection solution and how it can help you fasten your edgeai and computer vision product development. So, in summary, dataset-based testing and real-time deployment are the two major testing methodologies for your use case-driven testing scenarios. Each has its own pros and cons, and you need to have multiple combinations of this scenario to develop confidence in your model. This is Afuns signing off and looking forward to join you in yet another session of the vlog Unraveling Edge AI and Computer Vision for the Real World. Bye.